Hello students, look at another very good example of rectification. Show that the arc length of the curve 9ay square equals to x times x minus 3a whole square is 4a root 3. Now look at this curve first of all and try and understand how to plot this curve. Now we have 9ay square equals to, it is x into x minus 3a its whole square. So if a is given, you can understand what that a is, and based on that you decide the answer the problem. If a is not given, it is default understood that a is positive. So one choice is you either remember the construction or maybe plot of this curve and then you complete the problem. That is very simple method, one very simple option. But I would suggest you to try and understand how to plot this curve, because there could be many such curves. So let's invest some time in understanding the plotting of this curve. If I write y square equals to, it is x by 9a times, it is x minus 3a whole square. So you get one such curve. If you replace each y by minus y, you see you get same equation. It clearly means it shows symmetry along x-axis. If you replace each x by minus x, you don't get same equation. It means it curve is not symmetrical about y-axis. If you replace each y by 0, you get this product is 0. It means you get x is 0 and x is 3a. It means curve meets x-axis only in x equals to 0 and x is 3a. So 0, 0 will be appearing here, and 0, 3a, since a is positive, 3a lies to the right of a. Somewhere it is 3a comma 0. Curve meets x-axis only in these 2 points. Now because of this 2 point, the entire real axis gets partitioned in 3 parts. The part which lies to the left of origin, the part which lies between 0 and 3a, and the part which lies to the right of 3a. And here in each case try and understand what happens. Now here in this case, when I write x is less than 0, obviously it is less than 3a. So obviously it is x minus 3a is your negative. So here x is negative and x minus 3a negative. What happens here? X minus 3a negative, but square would be positive. But since x is negative, this would be negative. Y square is negative and no real y exists. Correct? So it means curve doesn't exist here in this part to the left of origin. If you look at this portion, x lies between 0 to 3a. So x minus 3a is negative and x is positive. So x minus 3a negative, but square would be positive. X is already positive, a is already positive. The entire RHS is positive, y square positive. It means it gives 2 real y, one positive, another negative. Positive lies in upper half, negative lies in lower half, and curve exists here in this portion. If x is greater than 3a, it means obviously greater than 0. So x minus 3a, it would be positive. Here x minus 3a positive, square is positive, x is already positive, 9a is positive, since a is positive. Everything is positive on right side. Y square positive, it means y gives 2 values, one positive, another negative, 2 real y exists, and curve again exists here in this portion. But here in this case, if x is allowed to approach to infinity, here it would be infinity minus something finite infinity. Its square would be infinity. Infinity into infinity would be infinity. Infinity into any positive constant would be infinity. In short, y square tends to infinity. It means y tends to infinity and minus infinity. And summing up all, you get a curve, and that appears in such a form. So symmetry along x-axis, not symmetry along y-axis. Curve meets x-axis only in 0, 0 and 3a comma 0. Curve doesn't exist to the left of x is 0. Curve definitely exists between 0 and 3a. It also exists to the right of x is 3a. And as x tends to infinity, y tends to infinity and minus infinity. And summing up all, you get a curve, and that appears in such a form. There is no name assigned to this curve, but it certainly forms a loop between here. So here in this case, it is show that the arc length of the loop, this is of the loop of this curve is this much. Now loop is formed between 0 and 3a. So this is the arc length. So here is the loop between 0 and 3a. So because of symmetry, you can find upper half and multiply by 2, you get total arc length. So here in this case, Now, since y is available in terms of x and variation of x is easily available, like x is 0 to 3a, so we can try using dy by dx formula. So here if I write now y is, it is plus minus basically root x by, you can write 3 times root a or root 9a, whichever you feel better, into it is x minus 3a. So basically you are getting two y values. If I take upper half and multiply it by 2, so I consider for simplicity, I take y equals to, it is positive root x by 3 times root a, into it is x minus 3a, and now I write dy by dx. So if I differentiate this y with respect to x, so 1 by 3 times root a will be kept as it is. First function root x into derivative of x minus 3a with respect to x is 1, plus second function is x minus 3a into derivative of root x with respect to x is 1 by 2 root x. And then based on that you can write this is 1 by 3 times root a, it would be how much? 2 times x plus you get x minus 3a, and this is upon 2 times root x. Now this gives 1 by 3 times root a, it would be 3x minus 3a by 2 times root x. So 3 on cancellation, you are left with 1 by 2 times root a times root x. It is into it is, I can write x minus a or x minus a upon this much. If I write 1 plus dy by dx, its whole square, so this gives 1 plus, here it is x minus a square upon, it would be 4a times x. If you simplify, it would be 4ax plus x square plus a square minus 2ax upon, it will be 4ax. Now this is giving you x square plus a square plus 2ax, so it will be x plus a whole square upon 4ax. Now find the total arc length. So if I write total, this is arc length, this is of the loop of 9ay square equals to x times x minus 3a whole square is given by s, and this is twice the arc length, it is arc length in the upper half. So this gives 2 times the arc length, so it is between x1 to x2, it is root of 1 plus dy by dx, its whole square times dx. So it will be 2 times within the limits 0 to 3a, so it will be 1 by 2 times root a into it is x plus a by root x, the integral taken with respect to x. So if I integrate further, so it will be 1 by root a times integral within 0 to 3a, so it will be root x plus a by root x times dx, so it will be 1 by root a times, it will be x raised to 3 by 2 by 3 into 2 plus a into x raised to minus half, so it is x raised to minus half plus 1 is 1 by 2 upon 1 into 2. It is between 0 to 3a. So here in this case if I write, it is 2 by root a, if I take 2 common, you get 3a raised to 3 by 2, it is upon 3, I took 2 already common, so it is plus a into it is 3a raised to half. So it leaves 2 by root a, it gives 3a into root 3a by 3 plus you get a times root 3a. 1 3 on cancellation, you get this is same term, so you get 2 by root a times 2a times root 3 root a, root a on cancellation, you are left with how much? 4a root 3. This is the arc length, total arc length of the loop of this curve. Very simple example. Thank you.